screen, right?
Yes.
Okay. So thank you for joining this NMRG virtual meeting. So the main meeting, I would say. So as Laurent put in the chat, please just add your name in the Etherpad so that we can keep track of people here. Just let me remind you a bit the goals of the IETF, and so as NMRG is a research group, as usual, we are not directly conducting standard development. We are more focusing on long-term research in this group as the IETF group, research group. Just as a reminder, so also you should know that that you are following the IETF policy. So please have a look now on this. That is reminder at each meeting, and about the the meetings and how we work in IETF groups.
Jérôme?
Yes?
I cannot see your slide anymore.
You cannot see my slide?
No.
Hello?
I don't know if it's the same for others, but I just see your login screen.
No, we don't see the slide.
Okay. Let me reshare. Okay, yes, it's okay. Let me share the full screen. Maybe it will be.
Just to be clear, we don't. Now we start to see something. Yeah, now we see the slides.
Okay, good. So it was just a reminder about the IETF policy here, and so you have all the reference regarding the different policy and code of conduct and all the different processes and so on. So what is also very important is for virtual meetings that we have kind of rules. So the third thing is that to ensure that you don't have your video activated, that you mute yourself when others are speaking, just to avoid strange and disturbing noise or echo. Important is that from the last meetings we started, to the two last meetings we started to record the sessions. I think, Laura, you activated the recording, as I see. So
yes.
Just to let you know that meeting is recorded and then will be available and will be put in minutes so people can replay the meeting in addition to minutes itself. Of course, when speaking, please, yes, if there are many people who wanted to speak, just raise your hand and state your name, just to be sure that we know who is speaking. Okay. So the links are here that you can also find in the agenda of the today's meeting. So as I said before, yes, if you go to the Etherpad, just add your name now, and that will help us then for writing the minutes as well. So for the agenda today, so after this short introduction, we'll do an update of the group and status and on the different points and meetings of the group. And then we will have today one technical presentation from José Suarez on graph neural networks for networking. And then we have different discussion, and that's the main objective of meeting today, to have a discussion of the different items we have in our agenda in the group. So one on the artificial intelligence challenge document that I will summarize what are the last progress and how we'll continue, and also to discuss a bit some ideas that I will change in the shared document. And then we'll go into the different work item of IBM, in particular those that are in the next in the work plan that is defined in the charter of the group. And also we'll discuss the intent classification graph at the end, and then it will be the end of the meeting. So is that okay for everybody? Or someone wanted to comment or add something to the agenda? If we can. Okay, that's fine. So we'll go with the first presentation. And let me open the presentation from Jose.
Okay, hello everyone. So I will share my slides.
Okay, if you want, as you prefer. If you can share, yes, it's maybe easier. I just need to stop. Okay, that's it.
Can you see them?
Yeah, perfectly.
Okay.
Thank you, Jose. Jose, I will let you Agdel to start.
Okay, so thank you very much for inviting me also to present this work here. So I'm Jose Suarez Varela, and I'm at the end of my PhD program at the Barcelona Neural Networking Center, and I will present a work that we jointly did with these people that you can see also in this slide, which is entitled Fast Prototyping of Complex Graph Neural Networks for Networking. So first of all, I would like to discuss about what are the main characteristics that a design or an AI solution for networking needs to have to be a commercializable product. So basically, if we want to commercialize a product, we need to develop it in the vendor's lab or in the networking lab. And basically, we can have a controlled testbed and then an artificial intelligence model that can be a neural network. So in this scenario, what we can do is to train this model, and then this can result in a final product. But then this final product should be deployed in the customer's network and operate well. So the main barrier that we find with traditional AI solutions for networks is that they are not able to generalize to other networks that they didn't see during the training phase. And basically, when they operate in this, if you apply this final product in the customer network, the AI product will fail to operate well. So basically, it has issues to be commercially viable product. Another alternative would be to train directly the AI tools in the customer network. However, this is unfeasible since it would require network instrumentation, and also in optimization solutions, it may cause service disruption due to possible wrong configurations applied by the AI solution. And also, it's not feasible to replicate for every customer the network in a networking lab to train the AI product. So I would like to claim here that it's to have commercializable AI solutions. It's necessary to have AI models that are able to generalize to other networks that were not seen during the training phase. And in this context, the recently proposed graph neural networks were the unique AI-based models that were able to generalize to other networks that weren't seen during this training phase. So, for example, in recent works like RouteNet, the one you can see at the bottom of the slide, it achieved generalization with different topologies, routing configuration, and other elements such as the traffic in the network. So with this kind of models, we can perform an offline training on controlled testbeds in the vendor's lab, and then create a final product that can operate successfully on any customer network. So this, in this context, graph neural networks has the necessary characteristics to be a commercially viable AI solution for networking. However, considering the DNN-based solutions, one issue is that there is the necessity to create custom graph neural network designs for different, or to operate in different networking use cases. For example, to optimize the configuration in a quality of service aware network scenario, such as optimizing the routing configuration in your network, or other typical networking scenarios, such as optical networks, including modulation and spectrum assignment, or more modern paradigms, such as virtual network function scenarios. So each use case, in the end, requires to make a mathematical formulation to represent all the different network elements that are involved for this particular use case. And these elements should be represented in the form of graphs. So at the right, you can see, for example, the mathematical formulation of RoundNet, which is not a simple formulation. So it includes some elements like the topology, the routing configuration, the traffic, and it can be extended to other elements such as security policy and other, depending on the networking use case. So what we see is that we need machine learning experts nowadays that have high skills on neural network programming, including or considering some languages such as TensorFlow. So the main motivation of this presentation is that to boost the adoption of graph neural networks applied to networking, it is essential to simplify the implementation of fast DNN prototypes. So this serves as an introduction to the framework I will present today, that is called Ignition, and is a framework for fast prototyping of graph neural network models for network AI applications. So basically, what is this framework? This is a generic framework where you can have a network use case, and it assists users to create a custom graph neural network architecture particularly adapted to this use case. So this is an easy to use DNN toolbox for networking researchers and practitioners that do not have a specific background on designing neural network solutions. So the main motivation to present this framework is that nowadays, if you want to design a first DNN prototype, you have to deal with programming in some tensor-based languages, like the well-known TensorFlow, PyTorch, or the more novel approach of Huawei Mindscore. But all of them are based in complex tensor-wise operations. So if you want to create your own DNN design, you will need to deal with this kind of complex tensor-wise operations. And also you will have a lot of problems because of the complexity to debug your code in this kind of languages. And here I show us a small code snippet where a small portion of DNN architecture is implemented in the form of these complex tensor-wise operations. So in the end, we face a steep learning curve when we want to implement a first DNN prototype. So how it works? How works this the Ignition framework? Basically, first, you need to define your networking use case and the main elements involved. Like, for example, I want to optimize the routing configuration, the security policy, And I have some target metrics such as improving the network performance or detecting or making anomaly detection. So then the Ignition framework will assist you by offering a network abstraction to define the GNN architecture adapted to this networking use case. And finally, this framework automatically generates a TensorFlow code with the implementation of your graph neural network model. So you are completely oblivious of this complex programming in TensorFlow. So to show how is the workflow for users, basically a user can develop its own GNN solution in 3 simple steps that are the ones that you can see here. First of all is to create a GNN model description, then migrate the dataset to a standard JSON format, and finally executing the training and evaluation of your GNN model. So going through the first step, to create the GNN architecture, which is the most complex part of this process, we offer a very easy JSON interface to create this. So you can abstract from all the mathematical elements of the graph neural network. And in this case, we offer a network abstraction where you can describe the network elements that are involved in the networking use case and the relations between them. For example, to define the routing configuration in a network, you can define a link, the link element and the path element, and define relationships between end-to-end paths and links. And in this context, we provide a template and detailed documentation to fill this template and create the GNN model. So the second step is to migrate the dataset to JSON. Basically, in this case, in networking use cases, datasets have very different structures depending on how you generate and gather the data. So what we do is to provide a standard JSON interface that is easy to be migrated, or to migrate your data to this format. And finally, once it is migrated, you can easily fit your GNN model with any dataset. So once we have the dataset and the model architecture, the third step will be to train the model. And basically, you can do it with 2 lines of code, particularly for training. And then once you have also your model trained, you can use these 2 lines of code to evaluate and execute the training model. So compared to TensorFlow, where you can have hundreds of lines of code, here you have only 2 lines of code and an intuitive JSON interface to define your GNN model. Also, we provide an advanced debugging tool where you can visualize the architecture of your graph neural network model in an interactive graph. So here you can see some examples where we show some snapshots of this interactive graph with different parts of a graph neural network model called RouteNet. And as you can see, it can help to know how it's the GNN internally. So in the end, this framework also includes some properties and characteristics to identify potential errors, and also assists users to correct them. So just to recap the main advantages of this framework, the main advantage is that you can make a fast GNN prototyping, particularly targeted for networking practitioners and researchers that do not have any background on TensorFlow and other related languages. So from our experience, we can see that, or we could see that when you want to start with TensorFlow and these other languages, it can take some months to create a first GNN prototype. And also it's very difficult to debug it. while with our framework, with just few hours, you can create a first GNN prototype and run the training of the model. Another advantage is that since it is intended to create GNN prototypes for networking, we can support a broad variety of elements related to networking use cases. And finally, it includes this easy debugging property. So the main objective of this framework is to bridge the gap between the networking and AI communities to create GNN-based solutions. So additionally, we provide a public repository where we are adding some state-of-the-art graph neural network models that were already applied to networks, like the ones that you can see here as an example. I think, or we claim that that progress in an education in artificial intelligence cannot occur without this kind of public repositories, including implementations and datasets. So this public repositories should serve as a good material for education and advancement in GNN. Here we have a first open source implementation that you can access at this link. Finally, I would like to give you some updates on a challenge that we are running now that is called the Graph Neural Networking Challenge. So the problem that we devised for this challenge is that we accept neural network models where you have as input a network topology, a source destination traffic matrix, and different network configurations, considering different routing configurations and queue scheduling policies. And the model should predict the mean per packet delay on each source destination path of the network. So to this end, we provide a data set that is simulated in Omnet++ that includes several topologies and hundreds of configurations of routing, queue scheduling, and traffic matrices. And basically, in the evaluation part of this challenge, what we want is to test the generalization capabilities of the neural network solutions proposed by the participants. So what we do is that in the training data set, we include samples simulated in two particular network topologies. And then we test these solutions on samples simulated in a third topology that should be unseen during the training phase. So the objective is to test the capability of these solutions to make good delay predictions in this third unseen network. The target audience for this challenge is for networking practitioners and researchers, but also from machine learning experts from the AI community. And in this context, graph neural network is nowadays a hot topic that is attracting much attention. We also provide some resources to facilitate the participation, such as a baseline model, including a tutorial, and an API to easily read and process the dataset. And finally, we engage participants by using a mailing list. And all this challenge was organized as part of a broader challenge called the ITU IEAML in 5G challenge. So you can check more details at this link that you can see here, where there are some other challenges from other companies and universities. So I would like to take the opportunity to encourage participation and dissemination. Now the challenge is open to all participants around the world, and it will take around 6 months. So it will end around November. And then there will be a final conference where some awards will be given to the winners of the challenge around November and December. So this is all. If you have some questions or doubts, do not hesitate to ask.
Any question? Okay, so maybe I will start this question. So maybe you can solve this challenge. This is what you introduced last. What the participant will provide to you? They provide the neural network model. I'm not sure to. I understand the input that they will have. But what?
I can't hear you properly, but I think that you are asking about the input of the neural network solutions.
It's more what the participant will provide to you as a solution.
So they will provide neural network models. So the idea is that they can implement any model based on neural networks that should have as input the topology, the traffic, and the configuration of the network, and the output should be this the mean delay estimated on each source destination pair. So the idea is that we will give at the end of the challenge a test data set that is unlabeled, and they have to label this data set and send us the labels so we can compute the score of these solutions. And basically the score of these solutions is based on the error between the ground truth obtained by our network simulator and the labels of each participant.
Okay, so they have to use a particular format for the model.
Yeah, we will use a CSV format, comma separated format. Yeah. And they don't have to send us the solution, just the output of the model, and then once all the solutions are in a scoreboard or in a ranking, we will analyze the top 5 solutions. So we will request the solutions to check that they comply with all the rules of the challenge and that they are, for instance, based fundamentally on neural networks.
Okay. I have another question regarding the work you presented before the challenge. You present your solution, and you have a small example on one slide where basically you said you just need to describe as a JSON file the network and the problem. I think it was step.
Well, the idea for this first edition is that we provided a baseline implementation in TensorFlow, but in the next edition of the challenge, we plan to incorporate this framework so participants can use the framework to develop their own solutions.
Yeah, I was more asking what you put in the first step. I mean, not in the challenge, in the ignition framework. The GNN framework you present, I think, in step 1. Yes, where you put the GNN model description, and then you have an example. I think next slide. If you can, because I think it's very interesting because you say that basically you can. I mean, one challenge actually is that it's hard for non-expert people to design. I mean, to define the GNN. and it has to be adapted to each kind of use case or objective. But I'm not sure to understand in your model description how you can somehow describe the objective of your model. Like you say, it can be quality of service or whatever, but how will you put in this description, basically?
Well, the idea is that you can have this model. So the objective will depend on the output values in your data set. So here you define the inputs, the outputs, and how is the GNN implemented inside. So how is the internal architecture? So then once you train your model, you need to include a data set. And this model will learn based on the samples of your data set. So for example, in the case of RouteNet, if you have if you want to predict the source destination mean delay, your data set should have these output labels. But also in the case of directly optimizing models, you can integrate these kind of solutions with some optimization algorithms and some more novel solutions such as deep reinforcement learning, and then your model can directly learn the objective function according to a target policy in the network.
Okay. I think there was a question in the chat. So, Alex, do you want to ask a question yourself, maybe?
Well, I can see the question in the chat. So, how can I know if the neural network learned correctly about an optimized route? So basically, when you are training your model, this is part of TensorFlow and other languages. You will see the evolution of your loss function, and the loss function is basically a metric that tells you how accurate are the predictions based on the in your data set. So you can consider some thresholds for this loss function, and once the error of this model is quite low or is sufficiently low, you can consider that it is able to model all the samples. And usually one methodology to achieve this is to separate or to split your data in training, validation, and test data sets. So to complete the accuracy of your model, usually you train the data set in some specific samples and then evaluate the accuracy in other samples that weren't seen during the training phase. For example, in the case of the challenge, what we propose is to train the model in two network topologies, and then we evaluate it in a different topology. So if it's accurate in this third topology, it was able to generalize at least to this unseen network. Okay, I see. Do you recommend using the PCA? Well, I would say that in this process probably is not necessary, but maybe it can be useful to analyze all your features, your input and output features in advance. But usually in this process, the graph neural network model and in general neural network solutions are able to learn from your data, and also it's not necessary to make previous analysis on the data.
Okay, thank you, Jose. I think there is no other question. Thank you again for the presentation, and so I think it's good that you make also some advertisement for the challenge and people are willing to participate. I think it will be nice as well. Thank you.
Okay, so thank you very much for inviting me to this forum.
So let me return back. Okay, so I'm going back because I think I skipped a slide before the presentation. So I'm sorry for that, but wanted just to introduce you the future meetings that we will have in the group. So as you know, the IETF in Madrid will be online. It will be cancelled on site. So we will follow the guidelines that we receive for the group. If we want to have a slot for virtual meeting, I mean virtual meeting during the agenda of the IETF should be for 100-minute session, single one. That's the recommendation. I think that's the maximum we can have actually. It's a good time because at that particular time, and in next July, we have a set of work item and milestones, in particular regarding AI challenge, but also I think IBM architecture and a new document for the architecture. Of course, in research group, milestones are not as strict as in a working group, but still they are good. They are good to be there just to recall us also and to help us to a bit stimulate and the activity of the group. So I think it's good to have this milestone in July, even if it's very short, not regarding the delay, but it's good to have it. And there will be also today discussion regarding hackathon. And I think initial discussion was to have a hackathon in July. So as it will not be a physical meeting, and anyway we can have a virtual hackathon, something under discussion. So we'll also discuss today in the group what we could do. We hope that maybe in November we can have a physical meeting, but of course at that time nothing is decided for that. It will be face-to-face or online. Anyway, as we are used now, so we'll continue with monthly virtual meetings, meaning that we'll have another one in June before the virtual IETF meeting. And of course, we have always a mailing list, and we have set a number of accounts on different platforms on GitHub, on Google Docs that we use, for example, for the AA challenge document. So we'll continue with this mode of operation as written there. And of course, just you can use any kind of the different tools that we have to communicate with the group. Okay. So if there is no comment, I will also go now for the next item, which is about the challenge document. So just to remember to all that, so we started this document to list and have documentation about the different challenges regarding the application or the use of AI in our domain of network management. So last time the status was we basically started based on discussion we had in previous meetings. We started with some challenges in the document and with an initial table of contents, initial list. And of course, then there will be a kind of call for contribution to this document. I would like to thank all the contributors and future contributors because a lot of people reply positively but did not have time to contribute to the document. But at least it looks like we are now in a good shape regarding that we have a small team that can support the document and with inputs. So that's very nice. And here today, I would like to present, of course, a bit the discussions that happened in the different comments when people read the document and contribute to the document, but also we can discuss a bit more. And if people have opinion on the different part of what I present here, please feel free to interrupt me and tell me your feedback. So looking at the update in the document, so as I said, so there was some discussion and some proposition regarding the, let's say, introduction of the document, because of course, before going directly into describing challenges, we wanted to have some kind of introduction. So initially it was the introduction section, I would say, was focused on objective of artificial intelligence for network management. And there is a proposition, maybe rather than going from saying that we know the objective, first maybe focus or highlight the problem, I mean difficult or hard problem we have in our domain, and see how AI can help. So I personally think it's very related. It's just the way you present. So rather than saying that there are different objectives to solve this and this and this problem, it might be better motivated if we start describing the very hard problem we can have in our domain. So there were some problems actually that have been documented already, or at least listed. For example, everything related to resource allocation with NPR problems, where you have heuristics that are not optimal and so on. AI can do better and so on. And although it was highlighted, I think, I mean, we have all this problem of scalability, accuracy of our techniques, but also the problem of the bottleneck, in particular human bottleneck we have in many operation, network management operations. So we need human operator to still a lot of human operation to do. So this is this was so this new section was proposed. Before then we go into the goals. So as I said before, we need to find the right, let's say, articulation between the two sections, or right link. Of course, there is clearly a link. It's not yet fully defined if we need two or one section, but anyway, we need to motivate maybe the first two, and then go into the second one with the goals. Here we have a lot of, let's say, comments and discussion how we should organize, because of course we should not put for each objective one paragraph and just each after each. But we should somehow organize the section, maybe classify the different objectives, and kind of structure on the objective. At the beginning, we just say we can maybe go through by layer, but of course it's clear that there are some transversal layers, so maybe you need to have something per layer classification of the objective, but still all the objective transversal to different layers. Or maybe there are also some taxonomies that exist in our domain that we could rely on to use, and see in this taxonomy, maybe find use this taxonomy to classify the different objectives where AI can help. That's a possibility. Another possibility is that, okay, maybe we can start with a kind of everybody can just contribute with what you are teaching about the objective of AI for network service management, and try to find common, let's say, attributes. So maybe it's, in the first case, taxonomy, and the same taxonomy is more top to bottom. It's bottom-up approach, okay? And then, yes, there are different ways. So it's not yet fixed, of course. So here, just to give you a bit what are the status of the, let's say, discussion. It's virtual discussion because it's mostly by comments in the document. But of course, here, if you have any other idea, always should organize a bit the goal and this section about goals of AI for NM. It would be good to hear from you as well. Yeah, I think it's Laurent, right?
Yeah, Jérôme. So yeah, it's nice to see that there are, I mean, people willing to contribute and already several comments and exchange on the document. Relating to what you asked about this presentation or organization, I think it will be okay for the moment to work with based on what people bring as inputs. And I would say gradually think about the best way to present that. Maybe for me, I see it currently as being a draft. We have ideas about sections, but we should remain a bit flexible. And even if it's not completely stable now, if it's a goal or if it's a motivation or problems, I think it's a bit fluid, and we should maybe keep it like this as we mature our thoughts about the document. I would not see as a big issue concerning that we are still at the beginning of this document. Maybe when it's a bit more stable, we can rethink a bit more if the initial structure of the first section needs to be reworked.
Okay, thank you, Laurent. Yeah, I agree. I agree. And I think maybe it was kind of a small error because I think in the initial table of content we actually put kind of per layer objective, but of course at this stage we are in the early draft and we can easily then consolidate different things into something more with more structure. If there is no other comment, I will move to the next slide. So here I just list the, so this, of course the core of the document will be the challenge description, so challenge themselves. As I said before, we set a list of challenges that have been identified in previous meetings, in particular in side meeting during previous IETF meetings. And here just report the ones that are no a bit more, let's say, I mean, for which we have contributions or comments. So one is regarding lightweight artificial intelligence, if you want to embed into small devices like, of course, routers, switches, and so on. This is something that actually has already been proposed, and I mean, I've already described in I think 1 month ago that we have this. There are not so much update regarding this. We have some contributors that are interested to contribute, but not so more update on the content itself. Okay, we have some comments regarding. I mean, another challenge was also, and I think it's a bit reflects the technical presentation before. I think one big issue or challenge is that we have people that are not necessarily experts in artificial intelligence, and we need somehow to be guided to, I mean, to guide them to use artificial intelligence if they want to use for a networking operation, right? So we have also identified this problem, and it was more on, if you want to use artificial intelligence, what should be the algorithm to use for your problem? And of course, maybe the two-sentence description of the challenge was a bit very too strong, and I think I also agree with the comment we received is that probably finding the right algorithm is probably too strict. It really depends on the number of parameters. Because you can say that if you want to, I don't know, to detect attack, to predict the next traffic throughput on your links, it's not so easy to say that you should use this or this algorithm, right? So maybe we should come up here with a formulation of the problem, how to select or how to find the right trade-off between the accuracy you want plus the constraint and so on. So, I mean, it's kind of methodology for helping somebody not really expert in artificial intelligence to set right the problem and help them to refine his view of what should be then maybe the best fit for its own problem of the algorithm. Alex, you want to say something?
No, sorry. I just joined.
Oh, okay. I saw yes. Okay, no problem. So then the third one that has been proposed is a new one, is regarding the automated network data labeling. So somebody that has been written and that has been described here is that for many cases, I think we know we already have the problem of data that we put in the challenges, but more than just having the data. Most of the time, it's also hard to have data with labels that can be used for supervised learning. So here the challenge is more about, okay, so probably today, I think it's not so difficult to have data. I think if you operate your own network, so you can easily extract data from the different probes and so on. But of course, then if you want to do supervised learning, because many techniques today are more focusing on supervised learning, then you need to have some levels of your data. Having only the data is not enough. And nice discussion is that, of course, you can say that you have data from one side, and then you have problem from the other side, and the same data, of course, can be used for different problems. But should not be at the same level, or same level can be used for different problems. So there is not a one-to-one mapping between the labels that you can put on data and the problem. So it should be adapted. So it's more exactly what I put here, just fill the gap. You assume that you have telemetry or monitoring techniques that allows you to have data. Okay, that we can assume that we have, and then you have a problem, and that we may need to feed the data to this problem, in particular regarding the label. Of course, there are other, other issues regarding the data, more related to the, I would say, AI technique itself, like, pre-processing, normalization, and so on. But I think from an objective perspective, you need the label if you want, regarding the problem you want to address. Then there is a question, of course, regarding although the online monitoring and control of the quality and property of the estimators. Always the question is that usually you have algorithms that can work nicely with some offline data set or on testbed, but then it's very hard to guarantee that they will continue to be enough accurate under, let's say, under long-term perspective. Like it's important to know if you put an algorithm in place to, for example, to automate some operation in your network, you should know how long your solution can be applied without, for example, reapplying learning and so on. So it's important to know at certain point when your AI technique is not any more accurate and that your model is not any more accurate. And it's also something like, of course, there are problems that are not only specific to us, but we should, I think, for all problems, try to figure out what is the specificity of the problem in our domain of network management. So we have also to think about that. For example, here maybe we have, of course, we have systems that we cannot just stop and restart, and for the first one, of course, regarding the data as well, I think we already identified this problem of data in general, but if you want label as well, it's very, I think it's very hard in our domain as well. Yes, Albert?
Thanks. So I was listening to your presentation, and also I check on I read the document, and I'm one of the ones that said that was going to contribute, and I didn't do it yet, but I will. And I was thinking that also regarding Jose's presentation, the document has to some extent, a non-written underlying assumption that AI will be applied to a network and training for that AI will happen on that network. And I was thinking that that's a possible scenario, but a different scenario is that training happens at the vendor lab and the AI works on the customer network, where no training, there is no training. So probably, I don't know if you think it's relevant to consider also this kind of a scenario?
So you mean when you just basically, when you train a different path, right? I mean, different network, and as you present, like it's related to transfer learning, right? Or maybe I'm wrong.
Yeah. It's similar to transfer learning.
Yeah.
If we think about it, right, many of the neural networks that we use every day, like in our phones, have not been trained in our phones.
Right.
Our phones come with neural networks that have been already trained and that's it, and we use them.
Yeah.
So this kind of a scenario, which I guess it makes a little bit more sense from a vendor perspective.
Yeah. Yeah. Right. Yeah.
I'm not saying that this is the only valid scenario at all. I'm just saying that this is another scenario.
Yeah, you're right. I think it's good. Yes, of course we can check in the document or how to make. I think I think as a challenge we should have it, and that if you can contribute with Jose, it will be really nice.
Happy to, and happy to trigger some discussion.
Yeah.
Just to follow up on this comment, I mean, this is a perfectly fine situation. This is something we are doing. I mean, I'm speaking on behalf of Nokia here. We have development of model on our, I would say, internal infrastructures, and when we deliver models to customers, I mean, this is kind of based models, and they need to be, I mean, fine-tuned or trained to the specific operational environment where they will be used. So this is a fully valid model, what you were mentioning.
But you mean fine-tune or retrain?
Not necessarily retrain. It's in fact, you can have a base model, which is the output of what we have trained on our training data sets. Usually we have relationship with customers to get some trained data set, but once the operator is deploying the specific solution, there is a phase of specializing. So you see, when you instantiate, you will have some level of adaptation of the model to the actual deployment. And this could be, I mean, you can have, let's take when you have some AI algorithms that are running for base stations. You can have a kind of master model that reside in some places, and when you deploy it over, I don't know, hundreds of base stations, each of the instances will be specific. They will be close because they rely on the same master model, but each of the model will be specific. Then you have also some issues but this is more software engineering, but you have issues for model management and versioning of those machine learning models, even if they belong to the same master model.
That's cool, right? Because what, if I understood you right, what you're telling me is that it's not a binary. Either you train on the vendor's lab or you train on the operator's network, but rather there are many degrees, right? You can fully train on the vendor lab and then don't do anything on the operator, just inference, or there are degrees in between. So maybe we could reflect that. I never thought about these degrees in between. So maybe we could also reflect that on the document.
This is Alex, just as an FYI, so basically this is the topic of transfer learning. I think this is very valid, and there was actually at IM last year, the best paper dealt with exactly that topic. It was a topic on on transfer learning, which was written by Ericsson and KTH, I believe.
Just to, because we are getting into a little bit into the academic discussion, with GNN, you don't need to do transfer learning. the model should work on an unseen scenario without transfer learning. Then I agree with you. Then the real world is super complex, and I understand that in many instances you will need to adapt, modify, or do your own stuff to adapt it to the real world scenario. But GNNs are not transfer learning. It's just a model that works. But I agree, with transfer learning, you can achieve similar results.
Yeah. So that's interesting. I mean, we not come back to your presentation, but GNN is a kind of a generalization, basically, of the.
Exactly. Yeah. So before GNNs, you had to use transfer learning. Now with GNNs, you don't need to. That's a very broad statement, but more or less is correct.
You mean GNN specifically, or other families of neural networks?
GNNs specifically, they can generalize to any graph, even if they have not seen. So if your learning is based on graphs, which in computer networks is very traditional, you don't need transfer learning.
Yeah, as you say, if the problem fits with a graph representation.
Yeah, exactly.
Yeah. Because I don't want to take too much time for this discussion, but yeah, I think it's an interesting topic to be brought in the discussion for the document. Just to reflect that we have also investigated to combine, in fact, deep reinforcement learning. In fact, even based on neural network plus reinforcement learning plus transfer learning. For different usage, it can be first to depending if you have available data or not. So you may reuse your train model and apply it to the target domain. And you can use it also to as an assistance to the operator if you want to be able to plan or to deploy similar models into different regions or different part of your network, but they have a good level of similarity. You may have also indication on how much gain you can expect from the transfer learning of reusing existing model versus, training a model from scratch and the cost associated with training time, training resources, etc. So this is why I was asking if it's very specific to GNN, because in our investigation we show that for deep reinforcement learning plus transfer learning, you can also get very good gains on such application. So I don't think it's exclusive, but I was curious about the GNN.
So my understanding is that maybe I'm missing something. I'm not saying anything bad about transfer learning. I think it's a valid technique. I'm just saying that with a GNN, you don't need transfer learning because it is already understanding what a computer network is. So if it is a different computer network, even if it has not been trained for that specific network, it will be able to understand it. I think that those are different techniques that apply to different things. Which is strictly true is that GNNs do not make any sense if your input information is not a graph, or it does not have, it can be a graph, it can be a graph with features on the link, features on the nodes, whatever, but a graph. And just to finish, my understanding is that if the input information is a graph, then GNN should provide superior performance compared to any other technique, including transfer learning. If your input information is not a graph, then I think that there are many other techniques that you can use. I don't know if I'm clear or not really.
Clear for me, thank you.
Yeah. Well, thanks, Jerome.
No, it's okay. It's nice to have a discussion. So thank you. Okay, so maybe we move to just the two other items on this slide. I think you can still see my slide normally. So we had two propositions for IBM related challenges. So I would say it's good because it makes also some connection with, of course, the IBM agenda we have in the group. But also maybe we have to see if it's this item must be IBM specific. Maybe it's more my personal opinion, not because when I read the document, somehow I would say that it's not necessarily IBM specific. But so the first one is more related to interpreting high-level or natural language intents. So it's more related to use NLP or techniques or named entity recognition technique from NLP to have a better interaction with human. So it's related to also human in on the loop challenge. So I think one question arises is, of course, you can interpret intent, but can you also generate intent from current operation, or can you use this to help in diagnosis, or in the other way that rather than the user is providing intent, the intent or kind of intent, I would say, or human, let's say, high level or human readable information operated to user based on diagnosis of the network. So it can be, I think, it was in the comment, can be seen the two directions. And the other one, I think it's quite it's very nice, but it can be more generalized than only IBM. Basically, the role is how you define your action plan if you have an intent. So what should be the action to produce basically the desired outcome that is expressed in the intent. So as well here for sure, I think it's very, it's kind of having looking for something 100% automated is not possible, but basically it's kind of the goal that we would like to have, something that is completely, let's say, autonomous or whatever. But it should be, it's of course, it's really part of the challenge of AI for network management. If you can, mostly you just provide some inputs, what you want, and then produce all the action needed to have this output. But yeah, that's basically what had been proposed as a new challenge. So they are still, of course, in discussion. So I just present you the status now of the discussion. But of course, if you have any comment on that, you can also give your feedback. Okay, otherwise I'll just move to the last slide about that because I think we have then to move to the next item. So then just more some in terms of how we can continue to progress. So I think it's good, as I said before, that we now have a, let's say, a list of identified interested contributors. So I think we'll continue with this group with more maybe active discussion with specific emails and maybe meetings to continue to consolidate the document. Of course, everyone is welcome to participate. Maybe I will let's say flood a bit less the mailing list for asking for contribution. So we will continue to present the status of the document during meetings, and everybody can contribute. But as I said, maybe we'll have more dedicated meetings and mailing list between the contributors. But yeah, if you want to be added to them, it's fully open, of course. So basically, we continue on the same with the kind of same process. So with the shared document. Where we have still some comments, so we have some discussions in the document itself. So it's kind of it's kind of a document plus comment plus discussion. So it's very nice because it's very interactive. And then there will be the question of the format. I think up to now we can continue to share the document. Maybe something that we already say last time is that we may think of what should be the good outcome of the document. It can be a white paper or can be a draft and so on. So probably I think I discussed with some of you and what is the outcome of the discussion is that the draft. I mean, if you put that in a draft, it can be good both for the contributors because it gives visibility to this work and also to the group because here, of course, we have a shared document representing the meeting. But if you have a draft that is visible, it can be also very good, which does not then avoid another format if you want at the end, if you want to have this in another format. But at least it gives some visibility to this activity in the group, and I think this is also very good. And yeah, I think for this, that's it. So if you have any other comment or question.
Jérôme,
Yes.
if I understand correctly, the idea will be to organize dedicated meetings, like drafting sessions on the document. Is it correct?
Yeah, correct.
But this will be publicly announced on the mailing list. I think we should try to keep the link with all participants of the research group.
Yes, we can announce publicly, of course. I think the idea was for meeting we can announce it maybe for emails, because if you have discussion by email, maybe I don't know if it's good to flood all the mailing lists. I mean, if you just discuss internally between the, let's say, author of the document.
At least I think if we'd like to be able to involve as much people as possible, yeah, maybe flooding with too many comments, too many discussion we will lose the track. But I think we should try to be inclusive in the sense that if people can see that there are some momentum on the document, that there are some specific topic or issues being discussed, I think we will still be able to include everyone willing to participate. Because if it turns to be a bit more to dedicated meetings, then it's difficult for people that are in a kind of listen mode to be aware of what's happening. So maybe there should be some announcement about, okay, the next meeting will be, or the meeting will be every 2 weeks on this slot, and then maybe provide a quick summary of the main technical point that were discussed, so that people, if they feel an interest to get involved, they can at least get the high-level summary to know what's happening.
Yeah. Okay. Yeah, no problem. I think, as I said, it's really open, so just to avoid flooding people with emails. Okay, good. Okay, so next point is now regarding the discussion on IBM architecture. So Laurent, I let you leading the discussion.
So as discussed already a couple of times, I think you're all well aware we have a work plan defined in NMRG concerning activities for intent-based networking. A couple of those work items are already pretty well covered, and there will be a point on the intent classification activity at the end of this meeting. But I would like to highlight 3 topics that also have been shared on the mailing list before this meeting. And we would like to get your opinions and see what we could do to move it forward. So the first point is on IBM architecture or architectural considerations, which is work item number 4. I think you can read the description. This is not the main elements of discussion today, but more on the considerations. Yeah, thank you, Jérôme. So we shared on the mailing list a set of points to try to steer a bit the discussion on this. We had already in the past several documents that are now expired, but also some technical presentations from research group participants. And I think we would like to be able to trigger activity on that and really make progress. So, so on the consideration, the idea is that we should concentrate on clearly identifying for the architecture documents the problem statement and design goal challenges and principle and requirements. So essentially the last part of the sentence for the principle and requirements, what is important to consider for the scope of this architecture document. The second point on it should be really intent specific. The goal is not here to design another very general management framework, but to capture this how, because intent is essentially how you do something, and capture that from an architectural point of view. Of course, try to even aim for simplicity in the architecture, flexibility of our design, make it also extendable, and think about the integrability of our proposal with other automation framework or automation aspects that are being developed in other groups, in IETF, but also other standardization activities. I was an advocate to try to investigate if using principles from service-based design, service-based architecture could be beneficial in making this this aspect of being flexible and extensible. But this is more a specific consideration. I think a question that was raised several times that very important is to clearly define and agree on the scope and system boundaries of what we consider to be the scope of this, where this architecture should apply, what is on top of this architecture, what do we plug underneath, and what is below this architecture. Sorry. Actually, what are we controlling or interfacing with this intent-based system? So I think this is essential questions we need to clarify at the level of the research group in order to make sure that we output the right types of documents for this work item. Also, what are the typical user types that should be considered? There is a draft on intent classification that address those questions of types of intents and types of users, also technologies involved. So I think that could also be inspiration from this document, from this work. But I think from the architecture point of view, this scope, this boundary question is essential in order to avoid, specifying the wrong thing. Then there is the question if we should be aiming for use case specific type of IBM architectures, or if we should really try to come to an architecture that could be applicable to the most number of use cases, so more generic, common functionality, common building blocks as part of this architecture, and whether these questions raise some notion of trade-off to find in order to, if it's too general, maybe it will be a bit less obvious how we can apply it. If it's too specific to some specific use cases, then it's not portable to other other applications. So this is also an important question to consider. The next point is IBM coexistence with legacy management system and emerging management automation technologies and frameworks. So this is related to what I mentioned before with this integrability. So either complete greenfield deployments and integration with new approaches for automation, or also if we have existing deployed system or legacy systems, how the architecture and the functionality we aim to provide can also interface and operate with those existing systems. So there is then the question of interoperability between different intent-based systems. Let's imagine that you deploy this architecture, or you follow this architecture and deploy the functionality in different domains from a single or multiple operators. They may not be fully homogeneous, so the question of interoperation first, and interoperability between those different deployments may be a question to investigate and document as part of this initiative in the work item. Then the NMRG proposition, what is our, I will say, clear positioning? There have been already other attempts in other groups, in open source also, about proposition for reference models, architectures, and different forms of frameworks for intent-based networking. So what is our clear differentiator here, clear value that we want to propose? And of course, I say connection with related draft and presentation. This is to say that this is not beginning from scratch. We have in the NMRG at least a couple of different documents and presentation that we can use as a basis. So the point here is to get a bit your opinion, how we can try to bring this work forward in the research group. Now it's your time that you're supposed to say something.
Laurent, this is Luis. mentioned maybe the possibility of driving this through the use cases. Maybe that could be because maybe considering an architecture in abstract terms probably a little bit more complex to understand what would be the specific necessities to be addressed. So probably going through different use cases could help to understand what would be the needs, the kind of information that is required, the kind of procedures, and the kind even of elements to check and consider. So maybe that would be the vehicle, let's say, a more clear view of the necessities for that architecture, and considering that start driving kind of architecture, I think.
Okay, thank you. Olga, I see that you're in the chat, you're raising your hand. I don't know if it is for these questions now, or is it for something else?
Can you hear me? Hello?
Yes.
Okay, so I have 2 points in regards to that. I do think, of course, you have to start from the problem statement, requirements, and use cases. But the question is kind of, do we go with some kind of generic use cases or specific use cases? So in terms of the, when you say here, should we consider use case specific IBM architecture or try to have more generic common architecture? When you say use case, do you mean like, you know, in terms of provisioning, closed loop, things like that, or do you mean different solutions like, for example, 5G or different or optical or something? What would you consider with use case in terms of, because you can approach it with a generic common architecture, you can also approach with generic use cases.
Yeah. I don't have a specific preference here, especially because I was thinking about some use cases. This is the next point in the discussion, to suggest potential use cases that are different from each other so that we can learn different things and identify potentially commonalities. I'm not sure they will qualify as very specific use cases, but more generic ones. But as I say, I don't have a clear preference what should be the process to try to derive this architecture. But I would like to see happen is that manage to deliver a document or a set of documents that is valuable in the sense that it's reused either in the research community as being seen as a reference. That it means that we are quite complete and useful in what we relevant in what we have identified as being the key component and interaction of an architecture, and also could be reused, I would say, wider in the industry as some guidelines to understand what is, because I don't expect that this architecture will be only a one shot, that there will be, I would say, derivation of those potential architecture, so that people want to really develop solutions and make implementation out of that, can use it as guidelines to understand, okay, we have those key functionalities to develop, and there have been some guiding principles, some key aspect, either from data structure or from the type of interactions, the type of mechanism that should be thought about when we design the system, and this should be a kind of help to those implementation, and also with the goal that ultimately, even if we are done doing standards in the research group, that this is a stepping stone to help towards interoperable intent-based systems. Because if we have multiple vendors, multiple solution providers developing their solutions, we can still also aim to have some level of interoperability between different functionality or between different systems. If we can contribute to that, for me, this will be a very good goal of this architecture discussion. This is why I was also considering very important question about the scope, and what is our value proposition. You see, because if we redraft a complete architecture, then we will just compare to what the others have done, And then it's just a matter of maybe we will have more momentum, more adoption, we don't know. But if we manage to say, this is something that was missing, this is clearly addressing a gap or a need, I think that will contribute to something of value.
Because compared to, thanks for that, but compared to the, what we did before in the standards in terms of the use cases and different architectures, the main difference here is that we are bringing all of those two cases together to support the intent-based approach. So, for example, in other standards like TMF, MEF, or whatever, they could kind of pick the use case and say, and prioritize it and say, okay, I'm looking at provisioning now, but I will have it, monitoring would be later, or assurance would be later. For us, what we are bringing with intent-driven or intent-based approach is putting all that together and supporting intent-driven life cycle. So from that perspective, specific use cases, if we are saying, oh, we'll support this or this or this, may not be possible. We have to kind of bring them all together to support intent-driven approach on top of them.
So this is Alex. I have one comment, just one add-on comment, Laurent, to your original question regarding whether this should be use case specific or generic. My opinion is this talks about an architectural framework. I would think actually this has to be general. It cannot be, we would not want to have a separate framework for each different use case. But having said that, I think it would be beneficial to say, here's a general framework, and here's how it gets instantiated for different use cases. So perhaps have a set of use cases there which are basically used to basically exercise the framework and verify that they can be how they would be applied to those use cases.
100% with Alex. Jeff.
So another, Marino speaking, another point to take into consideration would be that if we follow specific use cases, right, and derive an architecture that has a specific scope, right, we may get into the trap of doing something quite similar to policy-based management, that the solutions were quite customized to specific sort of use cases, right? So I'm also pro a generic sort of architecture.
I would agree as well.
Okay.
And just another comment I want to say, I'll be quick here. I do believe there is already some material from different stakeholders for the architecture. So maybe you can put it in some place to have all those materials together.
Yeah. Are you referring to previous draft and presentation?
Yeah, we have previous drafts, presentation, just some slides somewhere where everyone can see what's already available. So maybe if there are already some things in those drafts, they could be reused. And
okay, just coming back to this generic or general aspect of the framework, for me, it still will be very important to define what I call the scope of the boundaries, because if we are talking about ICT systems, I can imagine, for instance, an intent-based system being deployed for an IoT, a home system, or whatever IoT type of environment, which could be very different in terms of type of intents and functionality involved than if I'm deploying in the core of a large operator for 5G systems. So for me, when we say general or generic, I think it will be beneficial for us in the NMRG to say, is this in scope of what we consider to be applicability of the framework? Even if maybe it will be applicable afterward, but at least at the beginning of our design process to say, we consider this to be in scope because this is where we will exercise the design, and this is out of scope. The same can be, horizontally in terms of, I will say, type of technology or type of use cases, and it can be also vertical. I will say, where do we start and when do we stop? I think in the presentation from Marino's, the southbound boundary was on as soon as the intent-based management system was outputting, interfacing towards, for instance, SDN controllers, Mano, etc. So those were considered to be out of scope of the intent-based system, and we were interfacing with those. There are intent-based systems that consider purely SDN. So I think we should really clarify the positioning of this architectural work in terms of scope, because otherwise we may first not share the same understanding of what the scope is, so it will be difficult to agree on the design. And then for the applicability and as Alec was mentioning, trying to exercise the deployment scenario. If it's not in the scope of what we have designed first, it will be difficult to make this exercise.
I agree the scope needs to be clearly defined, but scope is different from use case, right? That was the earlier question.
Yes.
Yeah, but it would be defined by use case.
Yeah, I think it depends also on how we would like to proceed. There is some usual approach to say we expect a scenario or user story use cases, and then we try to derive requirements out of that, and those requirements help to drive the scope and the functionality of the architecture. Another thing is to use use cases, a bit like Alex was mentioning, that let's say we have an architecture and we want to explain and try to exercise if this architecture is fitting to some typical use cases, and then we see the adaptation process to go from a generic architecture to a deployed architecture. It can be the same set of use cases for the two parts of the process. There could be a kind of fully bottom-up approach to say we just take a ground set of use cases and we identify commonalities to derive the common functional blocks and interactions. So I think this notion of use cases can be taken from a slightly different perspective also, depending on how we want to use them. Okay, so also for the sake of time, what I got, I think we have also our minute and recording that will help us, but I heard several inputs. Thank you for that. We try to summarize that after the meeting and come back to the research group with some sort of proposal to move this forward. Of course, everything will be contribution driven, so this will just be guidelines at the level of the research group to try to see how we want to address this work item on IBM. But I think we already have some indication of what people will be willing to do and how to do that, progress this work. So let's move on to the next slide, please, Sharon. And I think we partially touched that, even if here the discussion will be slightly different too. So the second point is on the IBM use cases. We have also a specific work item dedicated to that, essentially towards validation scenario and use cases for intent expression and function, and to assess the quality and completeness of the specification. So in the considerations that we have shared partially in the mailing list and with some of the people involved in typical use cases, this is a proposition that we would like to make. Potential use cases of interest. This is, again, an open list, and we have to see who will be willing to contribute to that. But at least the way I see that is you can have kind of typical use cases that will be in different settings. Potentially a 5G or / network slicing type of use case, because this will represent certain set of actors. It can be vertical industry, vertical actors, the telecommunication operator or multiple operators, and typical types of infrastructures in support of that. The second category could be around enterprise or data center networking, because this could involve different type of actors. the type of infrastructures and problems that are faced from an operational perspective could be quite different or complementary, at least, to what could be in the first category of use cases. And finally, the last family or last typical type of use cases could be more towards smart X. So this could be for typically digital smart home, smart city, that will involve, again, another type of actors. If you take, for instance, a digital home type of environment, you may typically have the user of the system that have no qualification, no technical qualification on the operation of the network. So the type of intent and the type of operation is expected from the network, and the automation level could be quite different from if you have, for instance, specialists that are from a telecommunication operator that are here to operate, and the type of intents could be quite different. So my idea will be to encourage to have at least to have a discussion in the research group and maybe identify those families of use cases that can come with different characteristics. For me, this will be interesting to see if we come back to our previous discussion, how well this generic architecture may adapt and fit, be applicable to these different families of use cases. But of course, I think the ground truth about these use cases is that we need to have participants that are willing and capable of progressing those use cases as part of the work of the research group. That said, I think we also have more recently a concrete proposal coming from Luis and Panagiotis on the transport slice intent, which is a bit targeted to be a specific application. I think this could be also a basis of the discussion on the use cases in the group, and see if there are other participants willing to join them, or if there are other participants that are willing to develop additional use cases, and so to have more than one use case that we can play with and learn from in the research group. The second bullet point in the consideration is again a proposition from the chairs for the research group to potentially define guidelines and common structure, common expectation, and even eventually a use case template in order to help support the development of this activity. We have seen, for instance, experience in other groups that if there are several use cases that are proposed, if they share at least a common structure, this could be useful for the comparison, but also to stimulate and help in the redaction of, in the writing of the use cases. So this is something we could provide for the research group if they are interested into that. And I think there is an important connection to be made with the document, the work on intent classification, because in this document there is underneath the classification bottom-up approach to have those different technologies, user types, intent types. That is, I think, could be a quite obvious relationship with the work on use cases. So if you have, I don't know, opinions, things you would like to propose, comments on this work item, it will be fine to read it. If there are not so much comment on this, something I would like to share with you is we had some offline discussion with Luis and Panagiotis about their proposal. They have a draft that they have presented a couple of times now in the research group.
Laura, I think from the beginning, the beginning of discussion, I have the feeling that the framework will be mainly driven by the use cases, right? Am I right?
Which work are you referring to? The general work on IBM?
Hello?
Yeah, maybe you can go on.
Yes, the framework will be driven by the use cases. So I'm not entirely sure if is that the case.
Yeah. So, and maybe if you can try to talk again. What I was about to say before Mehdi made his comment was, so there is the work from Luis and Panegotis on transport light intents that is aligned with a kind of use case. This will be developed further as part of the work of the research group. So we have discussed with them about positioning this work at least as a kind of use case document. And we had also interactions with Jefferson, which is one of the research group participants and secretary of the group. Based on his previous experience at the time of ANIMA and the work of autonomic networking as part of NMRG, there was a set of use cases that were proposed with a common structure to try to stimulate the discussions. And Jefferson was one of the few that say took this activity really to the end. This publication of an RFC highlighting the specific use case he had proposed on violations. So I think we could benefit from the experience of Jefferson at the time of autonomic networking in NMRG and see, I mean, we have asked Jefferson to, if he was willing to kind of, let's say, organize some discussion around these use cases, as I say, based on his experience, and try to see how we can stimulate this work. So we will make the connection with Luis and Panegotis for this first draft, but we expect also, if you have interest into that, a bit similarly to what we have for the research challenges in AI, to potentially dedicate specific meetings on use case discussions, so that we may also trigger some interest from more than just the current one involved into developing additional use cases on IBM. Okay, so Jerome, we may move to the next slide, please.
Yep.
Just for the sake of time, we are a bit overdue. So the last point of this IBM discussion is on implementation and the activity around hackathon. So we have another work item in the IBM work plan, which is dedicated to implementation and proof of concept. We had last October a dedicated meeting and first very nice interactions, proof of concept demonstrations, and some outcome we wanted to develop further. So the idea is to continue on those on this spread of activity, and we have again shared on the mailing list and asking now for you about a set of considerations. What are the expectations, the objectives from the activity around implementation on internet-based networking, and especially kind of hackathon activity? Whether we should also combine with first work on documents. So typically, for instance, the use cases that we just talked about and the architecture, and at which stage we need to really consider, I would say, put more emphasis on the implementation and development of prototypes for IBM. How can this be organized and developed? Virtual hackathons, virtual teams with dedicated platforms to support this using the GitHub, etc. So whatever we can make available at the level of the research group, we will try to support. Also, who is willing to take part in this activity, and there could be different types of participation. Actually develop the tools and the demos, but also you may also want to provide some development environment or infrastructure in support of the simulation, etc. So your participation is not only to develop code, there could be also some other form of support. Also to help us in planning a bit how we see this activity moving forward. It will be good to have understanding of how much resources you may be capable of putting in this activity for the next upcoming months. And we would like to, a bit for the use cases, try to organize dedicated calls with interested parties. We think we should at least try to share this common understanding of what we would like to achieve with this implementation aspect of IBM, and see if we can move forward with this one. And also, typically, what kind of outcomes you expect from the short to long term, from very individual, I would say, simple types of prototype and demos, to more integrated and also more, I would say, comprehensive type of reference tools and frameworks. So defining clearly our objectives and mode of operation could be the two main aspects here, in order to at least give us from the support of the research group what we could try to give you in terms of organization of meetings, access to the GitHub or other collaborative platforms, and understanding your requirements. Any thoughts on this?
So, Laurent, just to be sure, so the implementation to the use cases that we could, use cases in the architecture that we could work out in the previous work items, or do you foresee something that could be running in parallel, not necessarily linked with the other work items, just to understand what is your perspective on this?
So here it's just my thought. I mean, not necessarily as a research group chair. It's just that for me, I can see a lot of flexibility here. What we had in October was really we made a call for demo as part of a conference dedicated to NMRG IBM topic, and we got four demos, not correlated to each other, and we already had, it was already a very good basis of discussion and further has a lot of potential for further activity. So continuing in that sense, for me, will be already quite nice. But we also identify potentially that there could be connections between part of the tools. For instance, one was providing part of the functionality to define intent and maybe do some verification on intent, etc., with an interactive and iterative approach. Some other demos were really more on the I would say, derivation of intent into specific NFV-based systems or SDN-based systems. Some other were related to, or were having specific functionality that were not seen in other, like a calendaring or scheduling type of functionality. So there could be, depending, this is really dependent also on what the teams are willing to do and how much effort and interest they will see in collaborating together. But I think having individual demos, not necessarily linked to the architecture or to the use cases, is possible. If they are linked to the use cases and the architecture, I think this is more consistent for our work, but I don't want to create too much dependency or burden to make this happen. Having also connection between the different demos or I mean, proof of concept could also be a plus, because then we have more pieces of the puzzle together, and we can work also on this interoperation and adaptation function between the different pieces. So we may also be able to demonstrate a more complete intent-based system than just with individual pieces, and maybe also some factor of reusing components between them. But this is also putting, you see, additional constraints, because you need more coordination, you need to comply maybe with some specification from the other tool. So I think it's really a matter of what the teams will see as their own interest and the shared interest. For me, it's broad, and we have to see what people are willing to go into.
Okay.
But again, just coming back on one thing, if you see this notion of a hackathon, virtual hackathon, I think this is a bit different, because for me, I will see this as kind of event, an event in time, where we really want to say, let's bring together a set of participants, set of teams, and try to discuss and work together on a common output. Whereas I would say the default background activity could be more, I would say, more independent, more flexible. If we gather for a specific hackathon, it means that teams are willing to contribute together, and the goal is the collective contribution. And we have to see if such type of virtual hackathon is something that the people involved are willing to do and invest into, or if this is not practical for some reason and we take it out of the picture. Okay, so also in this globally for all these different discussion items on IBN, Jérôme, myself, we will make some summary of the output of this discussion and make a feedback to the research group and maybe some recommendation of what to expect to happen. And we will use that as the next step to proceed. Okay, so Jérôme, you can move on to the next slide or next. Yeah. You want to take over, Jérôme, or you want me to make the update for that now?
I can take over for this if you want to. So the last item is regarding the classification draft. So as discussed in the last virtual meeting, and so we requested the author to do a last round of comment before requesting the call for adoption. So I think we are now in the process to send on the mailing list the call for adoption for this document. So as they actually ask for comments and address some of them, and they explain that we'll address the user in the next iteration. And we were waiting for the, of course, for the go for all the authors of the document. So we got it yesterday. So in the next next today or tomorrow, basically there will be the call for adoption sent on the mailing list. And so I think everybody then can give their feedback for the adoption on it. But of course, we have a few minutes, so maybe if the maybe Olga want to say something about the last comment, or I don't know. It's open. Maybe you have a few minutes if you want to share something, Olga.
Thanks. I can maybe just say, add a few additional things, like, that I think we addressed the comments that were received online and offline. There were some comments that maybe it was not possible to address because it was about whether this draft is relevant or not for some of the stakeholders. They said maybe they have a bigger comments that we said, okay, addressed by other drafts. We asked for the adoption. We got some comments. Thank you. Additional comments. So thank you very much, Yahi and Magdi, for the new comments. And our initial proposal is that we replied on those comments, but we also have a list that we created for the comments that we will address in the next version of the document after the adoption. So we created that list that we would address in the future. So I don't know. I wouldn't go back in what we changed and what we added. I think we presented it several times and discussed around it. So maybe it's quite late now. So I wouldn't go presentation at this point.
Okay, thank you, Olga. So yeah, said so the call for adoption will be sent on the mailing list.
Maybe just for the chairs, that is the only thing, like that it would be important just maybe to get your feedback about some of the things that we addressed based on your comments.
Yeah, by the way, thank you for the reply. I got the reply from the authors. But I have a question. For example, if I want to kind of argue with them or have more information, should I do it like directly, for example, to Olga, or should I send it back to a reply on the mailing list?
I am one of the co-authors, and because some authors are in China and it's quite early in the morning for them, I'm here. But there are also other co-authors here
One
the
thing
list.
is, for example, if I want to reply again to the email that I received for the questions, for the reply, like if I want to argue more, like, you know, interact more with the authors, like should I send you, for example, an email directly to the authors, or should I send it back to the mailing list?
Maybe it's always better if you send us a mailing list, because then you can also, other people can see and also interact and so on.
All right, fair enough. Okay.
But maybe I can just ask verbally the chairs whether whether we addressed their comments in the way that they're happy with it, because we tried to engage all the comment authors.
Yeah, I mean, I didn't have time really to get deep in reply, but I'll get back to you by email probably. But yeah, thank you very much for the feedback, the reply.
At least the way I get Olga's comment is that, yes, you made good work to, I would say, take into account the comments, be clear about the communication, what were the proposal. So this is very satisfactory from our side, and this is why we think if the document is not ready for a second call for adoption. So for me, and maybe a message that I would like to convey, this is really chair to, but this is applicable to any research group document, not only specifically to this one, is that for me, an important change is that once the document change from being an individual proposal to a research group proposal, it becomes the baby of the research group somehow. And then we say collective responsibility, and especially from the authors that now become, I will say, initially it was their own thoughts that were providing inputs as part of the individual documents. Now they are becoming editors of the document on behalf of the research group, so that they have this additional responsibility to make sure that what is reflected in the document reflect the consensus of the one that are contributing to this document. So now the one that are contributing to this document is not only the original authors, but needs to take into account the comments and the views from the other participants that are actively involved into this document. I think this is something to be well aware for the conclusion of the research group documents if they need to progress to a IRSG review. That this is really being the job of research group document and editors of a research group document to make sure that the document is to the best quality and fitting the scope and purpose that it was designed for. Are there further comments on this discussion item number 5 on the interim classification, or more generally any other business for the meeting today? Jérôme, you have something else to add before we conclude our meeting?
For me, that's fine as well. So I think
for me too.
Okay, good. So I think we can close the meeting. So thank you to all.
Yeah. Thank you, everyone. Thanks for the good inputs. Thanks for the nice presentation, technical presentation.
So, we will
Bye.
We'll talk to you soon. Bye-bye.
Okay. Goodbye. Have a nice weekend. Bye.
Goodbye.